Let C be the circle centered at I of radius 2. And we're going to traverse the circle in the clockwise direction. And we want to compute the integral of 1 over z minus I dz along the circle. So we have a circle which we typically traverse counterclockwise. That would be considered the standard positive orientation. But this time we want to go clockwise. So the unit circle would be e to the it, t between 0 and 2 pi for the parameterization. But that would be counterclockwise. And if you want to go clockwise, then you could instead change it to gamma of t equals e to the it bar, which is e to the minus it. Then that will traverse clockwise. So in our case, our C is going to be given by z equals gamma of t equals, and now we have a center at I, so we have I plus, and then our radius is 2 and not 1, so we would have to multiply by 2 here. So 2 e to the minus it, where t goes between 0 and 2 pi. So there's a parameterization of our circle. So now let's compute the integral. The integral around C of f of z dz is the integral from a to b of f of gamma of t times gamma prime of t dt, where a and b are the endpoints for the parameter. So in our case, our function is 1 over z minus I. The endpoints for our parameter t along the circle will be 0 to 2 pi. F of gamma of t, so we have to put gamma of t in here. So gamma of t minus I. Well, gamma of t is I plus something. So gamma of t minus I is just going to cancel out this I right here. So we're going to get 1 over 2e to the minus it. And then gamma prime of t, the derivative of I is 0, and the derivative of 2e to the minus it is negative 2i e to the minus it. And now the exponentials cancel out, as do the 2's, and we're left with the integral from 0 to 2 pi of minus I dt. So this is minus 2 pi I. The second way of solving this problem would be to go in the counterclockwise direction and then multiply the answer by negative 1. Because when you reverse the direction, that will multiply the integral by negative 1. Let's check that. Let's try this method too. Let's say that we'll go counterclockwise and then multiply by minus 1. So counterclockwise, we would have z equals gamma of t, which is I plus 2e to the it, where t still goes from 0 to 2 pi. And now the integral is equal to the integral from 0 to 2 pi of 1 over z minus I, so gamma of t minus I, the I cancels out again and we get 2e to the it, and then times the derivative of gamma of t, which is 0 plus 2i e to the it, and then this is the integral from 0 to 2 pi of just I, and that's 2 pi I. And since we went the wrong way in this second method, we would have to multiply the answer by minus 1, and that gives us the minus 2 pi I.